This is 10-5. We're going to take a look at other algebra with sequences. So we're going to construct the arithmetic and geometric sequence from given information. Now, there's 4 examples. All 4 examples are unique. I ask that we look at all 4 examples. So this first one, it says, given a term and the arithmetic sequence and the common difference, find the explicit formula. So it's given us the 37th term. It doesn't give us the first term. It doesn't have us, it doesn't have us a list of what, starting with the first term, et cetera, et cetera. So if we remember the formula, a sub n equals a, or a sub 1, plus n minus 1 times the d. Common difference d. Well, we got to find what this initial value is. We need to find what that first term is. Well, we have enough information here to be able to find what that first term is. So if I were to plug in all the information, so my n is 37. This right here is my a sub n, because that's the 37th term. That is the value of it. And then here's my common difference d. So plugging everything in, I get 249 equals a sub 1 plus 37 minus 1 times 8. So now all we have to do is just solve for that a sub 1. So you're going to get 249 equals a sub 1 plus, and this is going to be 36 times 8. And so that's going to be 249 equals a sub 1 plus 288. We're going to minus 288 to both sides. And so that's going to give us a sub 1 equaling negative 39. So now that I have all the values, I can actually sit there and I can plug it in. A sub n equals my a sub 1 plus n minus 1 times my common difference, where n is greater than or equal to 1. So we just set up the equation, we plug the values in, we found what we needed, which was the first term, and then I was able to take everything and write out the formula. Now, we're going to take a look at the geometric sequence, but everything's essentially the same way. If I know that my formula is a sub n equals my first term times my r times n to the n minus 1 power, well, plug in the information that I have. So this right here is your n. This is the a sub n, and then there's my common ratio r. So I have 25 equals a sub 1 times, and then my r to the 4 minus 1, so that's 3. So we're going to have 25 equals a sub 1 times negative 5 to the third. Well, that's going to be negative 125. So then 25 divided by negative 125, that's going to give me negative 1/5. And that's going to be my a sub 1. So then plugging everything back in, I'm going to get a sub n equals my a sub 1 times my r to the n minus 1, where n is greater than or equal to 1. So once again, different formula, same idea. We have to set it up and then be able to solve it. Now example number 3. It says find the explicit formula for the arithmetic sequence given in 2 terms. Now, for this one, it's really important. They have to tell us what type of sequence it is because we need to know what formulas it's going to be. Now, for this one here, we get 2 values or 2 terms within the sequence, but we do not know what the common difference is. We also do not know what the initial value is, which I established and said those are the two most important values for us to be able to write the formula. In any situation that you get 2 unknowns or 3 unknowns or 4 unknowns, we have to be able to establish an equation per unknown. So in this instance, because I don't know 2 terms, I have to be able to establish 2 equations to be able to find what those are. Well, the only equation that I know is the actual formula that's involved with each type of sequence. So in this instance, the arithmetic sequence, I should write out the formula. So remember that right there is my n, and that's my a sub n. So I can write this out as 336 equals, I don't know what my first value is, so I'm just going to say a, that's right, that's our a sub 1, plus n minus 1 times my common difference. Because I don't know what that is. Now this cleans up to that. So now I can do the same thing with the other equation. So there's my n, there's my a sub n. So this one's going to be 7,362 equals a plus 38 minus 1 times the common difference. Now cleaning that one up. Now this is just a system of equations. So I need to consider these together. So I'm just going to write that one under this one. So 736. So 7,362 equals a plus 37d. Now I could either use substitution or elimination. I want to try and eliminate a variable. If you look at the a's here, I could easily eliminate those. So if I multiply this entire equation by a negative, so that's going to give me negative 7,362 equals negative a minus 37d. Now, if I combine these two equations now to create a new equation, that's going to give me negative 4,000 because I'm adding these two together. A and negative a give me 0, and then 17 and negative 37 are going to give me negative 20d. So now to solve for d, divide by negative 200 or negative 20, and that's going to give me 200. Now I need to take this and I need to plug it back into one of the equations, and I'll plug it into this top one. So I'm going to get 3,362 equals a plus 17 times 200. Well, that 17 times 200 is 3,400. So I'm going to minus 3,400. And so you're going to get negative 38 equals a. So I have my first term. I have my common difference. Now I can write the explicit formula. And that is my answer, where n is greater than or equal to 1. Last one. We're doing the same thing now, but this time we are going to use the geometric sequence. Now the math, in my opinion, this one's a little bit easier because you're not dealing with big numbers, but we haven't really did a whole lot with solving exponential equations, but everything works out nicely, and I'm hoping that this will, it'll work out. So same idea here. I don't know what my first term is. I don't know what my common ratio is. Because there's 2 missing variables, I have to be able to establish 2 equations. So we're going to use the information to do that. So for this one, this is my n, this is my a sub n. So 12 equals my first term times my r to the n minus 1. And that's going to turn into 12 equals a times, well, 2 minus 1 is just r. I know my R's look like V's. I apologize. My next one, this one's going to be my a sub n equals a times r to the n minus 1. And so that one's going to just be 768 equals a times r to the 4th. Now, if you notice in both of these equations, again, I can get a by itself really easy. So if I divide both sides by r here, I'm going to get a equals 12 over r. Well, on this side, I can go ahead and divide by r to the 4th. And so I'm going to get 768 over r to the 4th equals a. Well, now that they're both a, I can set them equal to each other. So I'm going to get 12 over r equals 768 over r to the 4th. Now getting r by itself. Probably easiest to just to multiply both sides by r to the 4th. So I'm going to get r to the 4th times 12 over r. Well, that's going to cancel out into r to the 3rd. And that's going to equal 768. Now divide both sides by 12. So we're going to get r to the 3rd equals, and then 768 divided by 12 is 64. So now I can cube root both of these. So r is going to be 4. Now I can take that and plug that into one of the equations I've already established. I'll plug it into this one. So 12 equals a times r. Divide both sides by 4. A equals 3. So now that I have my a and I have my r, I can establish it and write my equation. So a sub n equals my a times my r to the n minus 1, where n is greater than or equal to 1. So, what did we learn today? We learned how to establish the arithmetic and geometric sequence based on more abstract information, whether it's just values within the term or maybe a value and the common difference, but we were able to establish it for both the geometric and the arithmetic sequence. And so just as a reminder, the two values of the geometric sequence that we need is the first term and the common ratio. And then I'm just going to throw in there the arithmetic sequence. So the two important values there are going to be the first term and the common difference. This does conclude our lesson. If you have any other questions, please leave them in the comments.